So we're looking at graphing, and just like we did before, our A's, our B's, our C's are still going to stand for the same things they did. We just need to find the center first. So if I'm asked to graph something like this, and it's already in standard form, what I like to do a lot of times is, first of all, we know what kind of graph is this going to be? It's going to be an ellipse. So we know we're looking at an ellipse. And the reason I like to think of what we're doing is then that at least gets in your mind, okay, ellipse. Ellipse, what's the relationship between A, B, and C for an ellipse?
A squared minus B squared equals C squared.
Right, so we know A squared minus B squared equals C squared. A squared minus B squared equals C squared. So just taking a moment to identify the type of graph, that gets us thinking, okay, what do we know about it? Yes, Omar?
I kind of just blanked out on this. Since we have x minus 3 and y plus 5, do those represent the coordinates then? Or of like
Okay.
the center? I can't remember.
So when we just had x squared, what number did we have to put in for x to get the 0 squared? What number do we have to put in for x now to get 0 squared? 3. So the center is now 3, negative 5, right? So what I like to do then is I go to my graph and I'm going to plot 3, negative 5. I'm going to 1, 2, 3, 1, 2, 3, 4, 5. Okay. And a lot of times it's not actually a point on the graph, so I might just put an X there. So I know that's the center. So then we're going to go through and we're going to, is this ellipse going to be more horizontal or more vertical? I mean, we're both. Jackson, why are you saying vertical? Right, 9 is bigger than 4. So let's see, what's our A value? And what's our B value? What's our A? 3, right? Because it's the square root of 9. And here we have the square root of 4 is 2. Okay, so let's see, this was with our y. So that tells me, okay, from my center, I'm going to go up and down 3 to get the vertices. So if I went up 3 from the center, 1, 2, 3, here's a vertex. I'm just going to label it V1. And let's see, well, we have the coordinates there. It was 3, and we were at negative 5 for the y, we went up 3. So now we're at negative 2. And if we're here and go down 3, 1, 2, 3, our second vertex would be 3, negative 8. And then our B, well, that was with our y. So I'm going to go from the center, left and right, 2. So that would give us, let's see, this center was 3, negative 5. So if I went 2 to the right, we get 5, negative 5. And if I'm at 3, negative 5, we go left 2. Well, that would take us to 1, negative 5. And then the other key points with the ellipse are the foci. Okay, so then we're going to go ahead and find the foci, which means we need our C. So I go back to this, the fact that A squared minus B squared equals C squared. A squared minus B squared equals C squared. So let's see, that would be 9 minus 4 equals C squared. So 5 is C squared. Also minus the square root of 5 equals C. And if we're thinking of C as strictly in terms of the distance, obviously it's just the positive square root of 5. If I'm thinking of what I need to do from the center, then I can think of this as plus and minus, because I'm going to add the square root of 5, and I'm going to subtract the square root of 5. Now, square root of 5 is a little over 2. It's like 2 1/4, about. So when I plot it, obviously we don't have square root of 5 listed on our axes, but we can get pretty close by getting the decimal approximation. So let's see. foci going to be along the horizontal? Are they gonna be along the horizontal here? Or the vertical part? Where should they be at? On the vertical, right, because it's always on the major axis, which connects the vertices together. So I'm gonna go up about 2 1/4, 1, 2, be here, and there's, I'm gonna label that F1. Let's see, we're at 3, -5. We didn't go left, right, so we're still at 3. And then our y-coordinate, we're at -5. And we went up the square root of 5. I'm just gonna label it that way. I wouldn't bother to get the decimal approximation. And then here, we're at 3, -5, we went down. So we went straight down from 3 to -5, so we're still at 3 on the x-coordinate, -5 minus -5. And then we finally just sketch in our ellipse. Now, obviously, with the hyperbola, it's going to be a slightly different process because your graph looks different. But it's very similar. You figure out where your center is, you figure out what your A is, what your B is, what your C is, and you make the appropriate graph based on those things. This one.
So our coordinates for the foci are 3, -5 or 5, you said?
3, -5 plus the square root of 5. Because we started at -5 on the y-coordinate and went up square root of 5, so that's why it's plus square root of 5.
Okay.
And then here, starting at -5 on the y-coordinate, going down square root of 5 more, 5 minus square root of 5.
So whatever you give for the value of c is how much more up or down or left or right going. You go based on what the major axis is.
Yes, yep, exactly.
Gotcha.
And you're always comparing it to the center. That's why it's just like what you did before. With the new thing is you need to figure out the center first. Once you get the center, you still do your A's, B's, and C's all mean the same thing.